May 1945. Lechfeld Airfield, Bavaria. A quiet hum fills the air as an American test pilot cuts the engine of his P-47 Thunderbolt and climbs out. His boots sink into the torn runway, scarred by the devastation of bombs and craters. The landscape is an image of destruction, but amidst this, across the field, something catches his eye. Something that shouldn't exist. There, sitting in the shattered silence, is a fighter jet unlike anything he's ever seen. A sleek, predatory-looking machine with no propeller. Its lines are impossibly smooth, its shape almost alien. Beneath its swept-back wings, two massive engines glisten in the sunlight. The German mechanics standing nearby watch in silence. Their faces are a strange mix of pride and defeat, knowing their country is on the brink of collapse, yet still holding on to the promise of their technological advancements. One mechanic, finally breaking the quiet, speaks in halting English. "This is Schwaller. You call it swallow. It is the future." The American test pilot stares at the jet, confused. He circles it, his instincts screaming that this machine should never be able to fly. Yet, the scorch marks on its fuselage and the warmth radiating from its nose-mounted cannons tell a different story. This aircraft had already seen battle. The Allies didn't know it yet, but this Swallow was more than just a weapon. It was a warning, a glimpse into a future where technology outpaced the very resources and people behind it. And within weeks, the wreckage of this jet would be packed up and shipped to America under a top-secret operation, Operation Lusty. There, in the heart of the United States, engineers would tear it apart, fly it, and test it against America's own first generation of jets. What they would discover would forever change the course of aviation history. But there was one crucial question. Why had Germany built the most advanced fighter in the world and still lost the war? The story of the Messerschmitt 262 begins long before May 1945, before the wreckage of these advanced jets became part of the spoils of war. In April 1939, months before World War II even started, the German Luftwaffe set its sights on an ambitious goal: to build a revolutionary fighter aircraft powered entirely by jet propulsion. While the British were simultaneously working on their own jet technology under Frank Whittle, Germany pursued a parallel path, driven by Hans von Ohahn's turbojet designs. What emerged from this vision was the Project 1065, a fighter that looked like something from a futuristic dream. But the road from concept to reality would be anything but smooth. The first prototype, a machine far from the sleek beauty we'd later recognize as the 262, took to the air on the 18th of April 1941. However, instead of jet engines, it was powered by a conventional piston engine, Junkers Jumo 210, mounted in the nose. This was not the promised jet. The intended BMW 003 turbojets were still years away from being ready, and when they finally arrived, the prototype's first test flight didn't go as planned. Both jets failed before the plane even completed a single flight, and the pilot was forced to limp home using only the propeller engine. It wasn't until the 18th of July 1942, more than a year later, that the Messerschmitt 262 finally flew successfully on jet power alone. But even then, the challenges continued. Engine failures, metallurgical problems, and material shortages plagued the project. The German Luftwaffe was losing the war, and high-ranking officials like Hermann Göring repeatedly cut funding for jet research. On top of that, Hitler himself interfered, insisting the Messerschmitt 262 be developed as a bomber rather than a fighter, decision that diverted critical resources and delayed its operational rollout. By the time the 262 made its debut in combat in July 1944, more than 5 years had passed since its inception. Germany, at that point, was losing the war on all fronts. Allied bombers relentlessly pulverized German cities and factories. The Normandy invasion had already begun. Yet, despite all of this, the Messerschmitt 262 was poised to change the course of aerial combat. When the Messerschmitt 262 finally entered combat in the summer of 1944, it was not just another aircraft, it was a glimpse into the future. Its sleek design, deadly armament, and speed made it unlike anything the Allies had faced before. But what made it truly terrifying wasn't just its raw power. It was the fact that, for the first time, Germany's enemies were facing a machine that was, in many ways, ahead of its time. The first operational Messerschmitt 262 seconds entered the fray when the skies over Europe were already crowded with American and British bombers, and the Allies had overwhelming control of the air. Yet, in those critical months after the Normandy invasion, the Messerschmitt 262 proved that it could still shift the balance. A typical 262 fighter variant weighed around 14,400 pounds, fully loaded. Powered by two Junkers Jumo 4B turbojet engines, each producing nearly 2,000 pounds of thrust, the Messerschmitt 262 could reach speeds of 540 miles per hour at 20,000 feet. That was a full 120 miles per hour, faster than the P-51 Mustang, the Allies' fastest fighter in Europe. Its armament was equally devastating. Four 30mm Mk-108 cannon mounted in the nose. These weren't just regular machine guns, they fired explosive shells that could tear apart a bomber with just a few hits. In fact, the German pilots referred to this as the Fist of God, a devastating cone of fire capable of ripping through bomber formations with brutal efficiency. The effect on Allied bomber crews was immediate and shocking. On the 18th of March 1945, a force of 37 Messerschmitt 262 jets intercepted a massive American bomber formation 1,000, 221 bombers, and 632 fighter escorts. The jets destroyed 12 bombers and one fighter in a matter of minutes, suffering minimal losses. Themselves, American pilots, caught completely off guard, described the jets as grey blurs, appearing from nowhere, striking with pinpoint accuracy, and vanishing just as quickly. For pilots like Lieutenant Volmor Bodrol, the speed and lethality of the Messerschmitt 262 were horrifying. "We were cruising at 23,000 feet, about 300 miles per hour, he recalled. Suddenly, this thing came past us like we were standing still. No engine sound, just this weird whistling. By the time we turned to follow it, the pilot was already 2 miles away." The Allies quickly learned that conventional air combat tactics, chasing, dogfighting, simply didn't apply to the 262. It was in a league of its own. The 262 was faster than anything the Allies had in the air, and it could outclimb, outrun, and outgun any fighter. The only way to counter it, the Allies realized, was during takeoff or landing, when the jet was most vulnerable. It wasn't about who was the better pilot. It was about physics. The Messerschmitt 262 operated on an entirely different level, making it almost untouchable in combat. But there was one thing that the Allies didn't yet understand. The very technological superiority of the Messerschmitt 262 was also its biggest weakness. The same revolutionary design that made the 262 so powerful also made it extraordinarily fragile. While the Messerschmitt 262 appeared to be a game-changer, its fatal flaw was hidden beneath its sleek surface, its engines. Despite its incredible speed and firepower, the reliability of the Junkers Jumo 004 turbojet engines was woefully inadequate, limiting the aircraft's operational effectiveness. The problem stemmed from Germany's desperate attempt to build advanced aircraft with the materials available at the time. The Jumo 4B, a marvel of design, was a compromise. It was a turbojet engine designed to push the boundaries of speed, but the materials used in its construction were substandard compared to what American engineers had access to. The turbine blades, made from Commodore alloy mix of iron, chromium, and manganese, were weak. They could not withstand the extreme temperatures and stresses that the engines experienced during flight. The engines were constantly breaking down. In fact, the lifespan of each engine was shockingly short, averaging between 10 to 25 hours of operation before a complete overhaul was needed. But most engines failed long before reaching 25 hours. The turbine blades would elongate under heat stress, leading to catastrophic failures. Bearings would seize, combustion chambers would burn through, the engines consumed themselves. It wasn't a matter of if the engines would fail, but when. American engineers studying captured Messerschmitt 262 seconds noted that the engines were made from materials that couldn't endure the heat generated during combat. The turbine blades operated in temperatures exceeding 800 degrees Celsius, while spinning at an astonishing 8,700 revolutions per minute. This was pushing the technology far beyond its limits. The aircraft's operational efficiency was marred by the need to replace engines constantly. A single Messerschmitt 262 required 2 engines, and these engines burned through so quickly that by the time the aircraft had flown just 50 hours, it would need at least 4 new engines. Allied pilots and ground crews lived in constant fear that the engines might fail during takeoff or landing, the most vulnerable moments of any flight. Lieutenant Roy Brown, one of the first American pilots to test fly the captured Messerschmitt 262, reported engine failures during training. On one flight, the engine seized completely mid-air, and Brown was forced to make a harrowing single-engine landing. The failure wasn't isolated on many occasions. Pilots had to eject or crash land after engine failures. Even with the best maintenance crews and procedures, the aircraft's performance was still limited by its unreliable power plant. For Allied mechanics, the challenge was just as daunting. They could replace a Jumo 4B engine in about 30 minutes, but doing so repeatedly meant that ground crews spent more time changing engines than pilots did flying. The maintenance burden was unbearable. The need to constantly swap out engines meant that the Messerschmitt 262 couldn't be used as effectively as the Germans had hoped, especially in combat conditions where downtime meant defeat. This was a stark contrast to the American approach. In contrast to the limited production of the Messerschmitt 262, the US had an industrial capacity that was on a completely different scale. American engineers quickly learned that reliability was as critical as speed and firepower. While the Messerschmitt 262 was faster and better armed, the Americans would soon capitalize on their ability to mass-produce jet engines that were not only fast, but also reliable and capable of lasting longer under combat conditions. But even with the constant engine failures, the Messerschmitt 262 posed a new threat, and the Germans, desperate for a change, still pushed forward, hoping that their technological innovation would give them the edge they so desperately needed. By the end of the war, the Messerschmitt 262's promise was unfulfilled, but its impact was undeniable. Despite the aircraft's inability to achieve strategic dominance during World War II, its technology became a crucial piece of the post-war aviation puzzle. American, Soviet, and British engineers took a hard look at what the Germans had created and absorbed invaluable lessons that would shape the next generation of jet fighters. When the Messerschmitt 262 was captured and sent to the United States under Operation Lusty, American engineers dissected the aircraft with a level of focus that rivaled the Germans' original development efforts. They saw a design that was light years ahead of anything they had in their arsenal at the time. The jet's swept wings, a solution to the problems of aerodynamic drag at high speeds, were revolutionary. This design principle would later become standard on nearly all jet fighters. The Messerschmitt 262's wings were designed to correct a major problem in early jet fighters, the drag caused by straight wings at high speeds. The Germans understood that as aircraft approached the speed of sound, air pressure against straight wings increased dramatically, leading to control issues. By sweeping the wings backward, the Messerschmitt 262 allowed airflow to slide off more smoothly, reducing drag and increasing the aircraft's speed. American engineers quickly realized that their own jets, like the P-59 and early P-80 variants, were fundamentally limited by their straight wing designs. The 262's aerodynamic advances prompted an immediate rethink in American jet development. The swept wing, once seen as a strange novelty, became an essential feature for all high-speed jets from then on, including the US F-86 Sabre, which went on to dominate the Korean War skies. But the technological innovations didn't stop with the airframe. The Messerschmitt 262's engines, while deeply flawed in their execution, still held valuable lessons. The US gained critical insights into jet engine design, particularly the idea of axial flow turbojets, which would later be perfected in American engines. The Soviet Union, too, reverse-engineered the 262's Jumo 004 engine, adapting it for their own early jet fighters like the Yak-15. In the UK, British engineers studied the swept-wing design to enhance their own jets, leading to improvements in aircraft like the English Electric Lightning. The influence of the 262 can even be seen in the Boeing B-47 Stratjet, the backbone of America's Strategic Air Command, in the 1,950 seconds. The B-47's wing design, which was crucial for its high speed and high altitude capabilities, took heavy inspiration from the Messerschmitt 262's revolutionary aerodynamic features. Despite these technological leaps, the most important lesson wasn't just about hardware. It was about the relationship between technology, industrial capacity, and the ability to turn a good idea into a functional, reliable machine on a mass scale. The 262's failure to achieve its potential on the battlefield came down to the German inability to produce it in sufficient numbers, a reality that would forever alter the trajectory of military aviation. The Germans had created a stunningly advanced fighter, but they lacked the industrial power, materials, and resources to make it an effective weapon in war. This lesson would shape American aviation policy for the next several decades. In the US, engineers understood that technological superiority alone wouldn't win wars. What mattered was the ability to mass-produce advanced technology, maintain it, and support it with a reliable supply chain. The Messerschmitt 262 taught the world that technological advancement, without the supported infrastructure to back it up, was ultimately a losing proposition. And so, while the 262's engines continued to fail and its potential remained tragically unrealized, its legacy lived on in the skies. Its design elements found their way into post-war jets that would go on to secure American air superiority during the Cold War. The sweeping wings that allowed the Messerschmitt 262 to slice through the air like a predator's talons would become the signature feature of a new generation of jet fighters. But the real irony was that the Messerschmitt 262, while a failure in its time, had not only outpaced its creators, but had also outpaced the era in which it was conceived. It was, in many ways, a glimpse into the future, both a warning and a prophecy of the next phase in aerial warfare. And by the time American and Allied forces had fully dissected its secrets, they were already building jets that would dominate the skies for the next half-century. In the end, the Messerschmitt 262 became not just a symbol of technological brilliance, but also one of the most poignant examples of strategic failure in modern warfare. The aircraft's design was an engineering marvel, far beyond anything seen in combat up until that point. But despite its potential, it never had the chance to fully prove itself in the skies over Europe. The reasons behind this failure are multifaceted, rooted not just in the limitations of German industry, but in the broader strategic miscalculations that plagued the Luftwaffe in the later years of World War II. The 262's operational issues, especially with its engines, became a significant drawback. As advanced as the aircraft was, the Jumo 004 engines used in the Messerschmitt 262 were plagued by reliability issues that made the aircraft virtually useless in sustained combat. Engine failures were common, and pilots, often inexperienced with jet aircraft, were left with few options when their engines failed. Many pilots learned to prepare for the worst by keeping a close ear on their engines during takeoff and climb out. The slightest noise could mean imminent failure. Even the act of advancing the throttles too quickly could lead to catastrophic engine damage, sometimes destroying the turbine blades or leading to compressor stalls that could send the aircraft into an uncontrollable spin. This was a problem that German engineers could never fully solve. The materials they needed to make durable turbine blades and combustion chambers simply weren't available, and the manufacturing processes they used were not up to the task of building an engine that could withstand the intense heat and pressure of a high-performance turbojet. While the design of the Jumo 004 was elegant, the practical execution left much to be desired. But even as the Messerschmitt 262's engines failed to deliver consistent results, the aircraft's legacy lived on. German ace Adolf Galland, who commanded the elite jet unit Javeriana 44, was among the first to acknowledge that, despite the aircraft's clear superiority in performance, it was ultimately the logistical and industrial problems that undermined its potential. Galland admitted in interviews that the Messerschmitt 262 could have been deployed more effectively if it had been given the priority and resources it needed earlier in the war. However, even then, he was uncertain whether it could have changed the course of the war. Germany's industrial capacity was simply too limited to produce enough of the aircraft in a timely manner. The Messerschmitt 262 was never able to achieve the strategic effect that the Germans had hoped for. Its impact on the battlefield was limited to small-scale engagements, where it could inflict heavy damage on Allied bombers and fighter formations. But for every victory, there was a maintenance failure, an engine breakdown, or a shortage of fuel that grounded the aircraft. Even when the 262 did manage to engage in combat, its success was often fleeting. Allied bombers, flying in formations with fighter escorts, proved difficult to defeat. The 262's speed and firepower could rip through bomber formations, but it was often forced to disengage quickly due to fuel limitations or mechanical failure. It was a brilliant weapon, but one that could not sustain itself in a protracted conflict. By May 1945, when Germany's defeat was inevitable, the remaining Messerschmitt 262 seconds were scattered across the German landscape, abandoned on airfields, hidden in tunnels, or simply left to rot. The Luftwaffe's once mighty fleet of jet fighters had been reduced to a handful of operational aircraft, a fraction of what could have been. In the aftermath of the war, the captured Messerschmitt 262 seconds were sent to the United States, where engineers dissected them to understand the advanced technology they contained. What they discovered was both awe-inspiring and sobering. The aircraft's wings, its sleek design, its jet propulsion, all of these features were decades ahead of anything the Allies had in their own arsenal. And yet, despite the brilliance of its design, the aircraft's operational failures and the Germans' inability to mass-produce it meant that the 262 never reached its full potential. The Messerschmitt 262's legacy, however, was not just about what it was, but also about what it represented: the future of aviation. The aircraft's influence was felt in the development of American, Soviet, and British jet fighters in the years following World War II. The lessons learned from the 262's design, from its swept wings to its jet engines, would shape the next generation of aircraft that would dominate the skies for decades. But perhaps the most important lesson of all was the realization that, in warfare, technological superiority alone is not enough. The side with the greatest industrial capacity, the best supply lines, and the most efficient production systems will ultimately win the war. Germany's failure to fully harness the potential of the Messerschmitt 262 was a direct result of its lack of resources, its crippled manufacturing capabilities, and its inability to train enough pilots to use the advanced technology effectively. In this way, the Messerschmitt 262 serves as a testament to the dangers of technological ambition exceeding industrial reality. It was a fighter that represented the future, but that future was never fully realized due to the limitations of the world in which it was conceived. In the end, the Messerschmitt 262 was both a triumph of engineering and a failure of strategy, a weapon ahead of its time, but unable to shape the outcome of the war. Conclusion. The Messerschmitt 262, the world's first operational jet fighter, embodied the future of aviation. But as we've seen, its story is not just one of technological achievement, but of missed opportunities, strategic errors, and the harsh realities of wartime logistics. Its legacy, while still felt in every modern jet fighter, is a lesson about the limits of innovation when faced with the complexities of industrial production and resource management.